for my question, I chose number 70 from the Chapter 15 exercises of our OpenStax textbook, which reads, using the dissociation constant, Kd equals 2.2 times 10 to the negative 34th, calculate the equilibrium concentrations of CO3 plus and NH3 in a 0.5 molar solution of CONH363 plus. Now, as with all of these problems, the first step is to balance our equation. We aren't really given an equation right here, but we can write one. Now we're starting off with CO3 plus and NH3 and ending up with CONH363 plus, and I'll show you why in the next step. So we have CO, cobalt 3 plus NH3 yields equilibrium arrow CONH3 6 3 plus. Now cobalt, we have 1 on each side, so that's fine, that can stay, but we notice that we have 6 molecules of NH3 and 1 over here, so all we have to do is add a 6, and then our equations are balanced. Our equation is balanced. So why I wrote it like this is because in this problem we are given Kd. Now we don't have any known equation for Kd, but what we do have an equation for is Kf, which is the formation constant. Which is why I wrote the equation in this way. So what we can do is we know that K sub F equals the inverse of Kd. So what that means is 1 over Kd. So we have Kf equals 1 over 2.2 times 10 to the negative 34, which gives us a value of 4.5454 times 10 to the 33rd. Alright. Next, now that we have that, we are going to make our ice table. So, let's rewrite our equation. I'm going to switch colors. So actually I'm going to keep that white for now. We have CO 3 plus 6 NH3 yields CONH3 6 3 plus. And now we have initial change and then equilibrium. So our initial values, we start off with 0, because as it says here, we have 5 molar solution. So that is 0.5. Now for our change, we have plus x. Actually, for this one, we notice we have a funky little coefficient right there. So that's going to be plus 6x. And then for this one, we have minus x. Add those together, and we get x, 6x, and 0.5 minus x. Now we use this and substitute into our kf expression. So we have kf equals the concentration of CONH363 plus all over, whoop, all over the concentration of CO3 plus, and then N, that is not an N, NH3. Now, again, because we have this funky little coefficient that I set up here, we're also going to have an exponent of 6 on that. So substituting in values, we have KF, which we saw up here was this value, 4.5454, whoop, don't know what that did there, times 10 to the 33rd equals our change. So we have 0.5 minus x over x times 6x to the 6th. Make sure that this is in parentheses because it's the whole expression here. It's the whole expression here that's put to the 6th. So, our 5th step, solve. So what we have to do is take this and assume that x is much less than 0.5 molar. So that shortens our equation into something that we can solve into 4.5454 times 10 to the 33rd equals 0.5 over x times 6x to the 6th. Multiply this expression out, so we get 0.5 over 46656 times x to the 7th. So what we did is we applied the exponent to this and then to this, and then multiplied this x as well. So 6 to the 6th power is this large number, 46,656, and then we add x to the 6th times x gives us x to the 7th. Take this and multiply it by this to get an expression that is 2.1207 times 10 to the 38th times x to the 7th equals 0.5. Then divide by this number, 0.1207 times 10 to the 38th. And that gives us x to the 7th equals 2.3577 times 10 to the negative 39th. Now, what we need to do here is get rid of the exponent. How we do that is you could write it like this. However, you can't do that on a calculator. So what we can do instead is multiply it by 1 to the 7th, multiply this, or rather, put it to the exponent of, that's not a 7, 1 to the 7, 1 over 7. So in your calculator, do the caret, and then parentheses 1 divided by 7, close parentheses. Otherwise, it will put it to the first power and then divide that number by 7. So that gives us a final value of x equals 3.0324 times 10 to the negative 6th. But we're not done. There are 2 other things that we need to do first. 6, we have to check our assumption. We need to make sure that it is less than 5% of the initial value so that we know that there's not a huge error. So we take this value, 3.0324 times 10 to the negative 6, and divide it by 0.5, because initially this is where we've taken it from, this value. So we divide it by that, and that gives us 6.065 times 10 to the negative 7th. Multiply that by 100, that gives us 6.065 times 10 to the negative 5%. That is smaller than 5%. Therefore, it checks out. So that is a value that we can use. 7, what we need to do is substitute it back into the original ice table equations. So what we have up here, these things. These ones right here. So we were told to find CO3 plus. That had no coefficient, so that is just x, which gives us the value 3.0324 times 10 to the negative 6 molar. And then NH3, that was 6x. So you multiply 6 by this number, and we get 1.8194 times 10 to the negative 5th molar. We have to go all the way back to our original equation. Let's find the number of sig figs. We have 3 sig figs in 0.500 molar. So let's round it to CO3 plus equals 3.03 times 10 to the negative 6 molar, and then NH3 1.82 times 10 to the negative 5th molar. And that is our final answer for this problem.